Welcome to Miami Flying Club, Ground Training Series. Today, Aircraft Systems. Propeller. The propeller is a rotating airfoil, subject to induced drag, stalls, and other aerodynamic principles that apply to any airfoil. It provides the necessary thrust to pull, or in some cases push, the aircraft through the air. The engine power is used to rotate the propeller, which in turn generates thrust very similar to the manner in which a wing produces lift. The amount of thrust produced depends on the shape of the airfoil, the angle of attack of the propeller blade, and the revolutions per minute RPM of the engine. The propeller itself is twisted so the blade angle changes from hub to tip. The greatest angle of incidence, or the highest pitch, is at the hub, while the smallest angle of incidence or smallest pitch is at the tip. The reason for the twist is to produce uniform lift from the hub to the tip. As the blade rotates, there is a difference in the actual speed of the various portions of the blade. The tip of the blade travels faster than the part near the hub, because the tip travels a greater distance than the hub in the same length of time. Changing the angle of incidence, pitch, from the hub to the tip to correspond with the speed, produces uniform lift throughout the length of the blade. A propeller blade designed with the same angle of incidence throughout its entire length would be inefficient, because as airspeed increases in flight, the portion near the hub would have a negative angle of attack while the blade tip would be stalled. Small aircraft are equipped with either one of two types of propellers, fixed pitch or adjustable pitch. Fixed pitch propeller. A propeller with fixed blade angles is a fixed pitch propeller. The pitch of this propeller is set by the manufacturer and cannot be changed. Since a fixed pitch propeller achieves the best efficiency only at a given combination of airspeed and RPM, the pitch setting is ideal for neither cruise nor climb. Thus the aircraft suffers a bit in each performance category. The fixed pitch propeller is used when low weight, simplicity, and low cost are needed. Constant speed propeller allows the pilot to select the most efficient propeller blade angle for each phase of flight. On aircraft equipped with a constant speed propeller, the throttle controls power output, which is registered on the manifold pressure gauge. The propeller control changes the pitch angle of the propeller and governs the RPM, which is indicated on the tachometer. For takeoff, the blade angle should be set at a small angle of attack and high RPM. To establish a climb after takeoff, set climb power by decreasing manifold pressure, and decreasing RPM by increasing propeller blade angle. Torque. The airplane of standard configuration has an insistent tendency to turn to the left. This tendency is called torque, slipstream, P-factor and gyroscopic precession. Torque reaction. A propeller rotating in a clockwise direction produces a force, which tends to roll the airplane in a counterclockwise direction. Effective torque increases at low airspeed, high power, high angle of attack. The spiraling slipstream is the reaction of the air to a rotating propeller. This spiraling slipstream strikes the airplane's vertical stabilizer on the left side. This pushes the tail of the airplane to the right and the nose of the airplane to the left. Asymmetric propeller loading, called P-factor. P-factor is caused by the downward moving blade on the right side of the propeller having a higher angle of attack, a greater action and reaction, and therefore a higher thrust than the upward moving opposite blade. Gyroscopic precession is the result of a deflective force applied to a rotating body. The resultant action occurs 90 degrees later in the direction of rotation. I hope I gave you some value information today that helps you. I would love to have you join the club, so thank you for watching today. Have a great day. Fly safe and fly smart.